There is a way to pull the hot air out of a house all summer using nothing but sunlight and a black painted box on the roof. No fan, no motor, nothing plugged in. The hotter the day gets, the harder it works, which is the opposite of almost everything else you own. And in January, the same box will quietly steal the heat you are paying for and throw it out through your roof. Unless you understand one thing about it that most people who build these never mention. I'm going to show you exactly what this is, what it costs, how it gets built, and the honest answer to the question in the title, because that answer is the whole reason this video exists. Last August, I stood on a ladder holding an anemometer at the top of a black duct I had built up the sunny side of a shed, and watched air pour out of it at a steady clip on a windless afternoon. Windless. There was not a breath of wind that day, and there was air moving up out of that duct like something was pushing it. Nothing was pushing it. It was being pulled, and the thing pulling it was the sun sitting on a piece of painted steel. Then I came back to that same shed in December, put my hand over the top of the duct, and felt warm air leaving it. That was heat I had paid for, walking out through my roof on a cold day. That contrast is the whole video, and it is the answer to the title. Here's precisely what this does. It creates a column of air hotter than the air around it at the top of your building. Hot air is less dense, so it floats up and leaves. When it leaves, it pulls replacement air in from wherever the easiest opening is, and if you choose that opening deliberately, you have made a ventilation system with no moving parts. That's it. That's the entire trick. Here's precisely what it does not do, and I want to say this in plain words. It does not cool air. It does not refrigerate anything. There is no cooling effect inside that box at all, and if you touch the duct on a hot afternoon, it will burn your hand. What it does is move air. It empties your house of hot air and pulls in whatever you point it at. If what you pointed at is cool shaded air, you get cooling. If what you pointed at is a sun-baked driveway, you have built a machine for filling your house with hot air very efficiently. Everything useful about this comes from that one sentence, and the intake decides everything. Cost: a sheet of polycarbonate glazing runs $30 to $60. A length of steel or aluminum for the absorber plate, painted matte black with high temperature paint, is $20 to $40. A timber for the frame, $20. Foil tape, sealant, and screws, $15. And a damper you can close, which is the part nobody budgets for, and the most important part in the whole thing, is $22.60, depending on whether you buy it or make it. So call it $100 to $200 and a weekend for a modest one on a shed or a single room. I spent a long career maintaining buildings where nobody would pay for anything that could not be pointed at, and ventilation is the classic example of that. We had a top-floor storeroom, flat roof, no shade, that ran genuinely dangerous in August. Boxers warped, anything with adhesive in it let go. The answer for years was to prop the door open, which did almost nothing, because propping a door at the bottom of a hot room does not give the heat anywhere to go. What that room needed was a hole at the top and a hole at the bottom, and something to drive air between them. I put a black duct up the sunny wall with a vent through the roof, and a low vent on the shaded side with a filter in it, cost the building maybe $200. That room came down 15 degrees on the worst afternoons of the year, and it never needed a single watt. Nobody thanked me for that one either. So I'm going to walk you through the whole thing in order. The science, the two holes, the box itself, the sizing, the damper, and then the winter question, which is the big one. And then I'm going to give you the part that ought to annoy you, which is that this is not new and not hidden. Every architect who has studied passive design knows it. It is in the vernacular buildings of every hot country on Earth. That history is worth 2 minutes because it tells you the design was solved long before anyone had a word for it. In Iran and across the Gulf, builders put tall towers on their roofs called wind catchers. Some caught prevailing wind and pushed it down into the house. Others worked exactly like a solar chimney, with one face heating in the sun and driving air up and out, pulling replacement air through the building from a shaded courtyard or an underground channel. Those towers cooled buildings in some of the hottest inhabited places on the planet, with no machinery whatsoever, for centuries. Mediterranean and North African courtyard houses did the same thing without a tower. A shaded courtyard with a fountain in it held cool, heavy air at ground level. The sunlit outer walls and roof drove hot air up and out, and the house pulled its air from the courtyard all day. Even the traditional English farmhouse understood a version of it with high ceilings, tall chimneys, and a cold pantry on the north wall. None of those builders knew the phrase stack effect. They knew that a tall, hot opening at the top and a low, cool opening in the shade made a house livable in August, and they built it into their architecture as a matter of course. Then air conditioning arrived, and within about 2 generations, we stopped designing buildings that ventilate themselves and started fitting machines to buildings that cannot. There's just no money in it. You cannot sell a service contract on a painted box. There is no refrigerant, no compressor, no annual tune-up, no filter subscription, and nothing to fail that generates a call-out. It is not a conspiracy. It is simply that nobody's living depends on you knowing it. If an old maintenance man's tricks are worth your time, hit subscribe and the thumbs up. It's the only way I know that you want more of them. Now the science, in plain talk, because you cannot size this without it. Warm air is less dense than cold air, so it floats on it, the way a cork floats on water. That is the whole engine, and it is called the stack effect. 2 things decide how hard that engine pulls. The first is the temperature difference between the air in your column and the air outside. The hotter you can make that column, the stronger the pull. The second is height. The taller the distance between where air comes in and where it goes out, the stronger the pull because you have a longer column of light, air floating on heavy air. That second one is why chimneys are tall, and it is why a solar chimney on a bungalow works less well than the same one on a 3-story building. So, a solar chimney is simply a way of cheating the first number. You take a duct, you paint the inside black so it absorbs sunlight, you glaze the sunny face so the heat is trapped inside like a greenhouse, and you point it at the sun. On a hot afternoon, the air inside that cavity can run far hotter than the air outside, and that difference is what does the work. The sun is not cooling anything. The sun is running the pump. And here is the elegant part. The hotter the day, the hotter your chimney gets, and the harder demand and supply rise together, which is a rare thing in any system. Now the 2 holes, and this is where people get it wrong. A chimney with no inlet does almost nothing. You cannot pull air out of a sealed box, so the design is always 2 openings, a high hot outlet, which is your chimney, and a low cool inlet, which is where your replacement air comes from. The outlet wants to be as high as you can get it, on the sunniest face, with a clear path to the outside. The inlet is where all the quality comes from, and it wants to be the exact opposite. Low down, on the shaded side of the building, ideally under trees or against planting, and as cool as you can find, every degree you save at the inlet is a degree you do not have to live with. And shade and vegetation both pull local air temperature down before it ever enters the house. Never put your inlet over a driveway, over gravel, on a sunny wall, near a dryer vent, or anywhere a vehicle idles. You are going to breathe every cubic foot of it. Screen it properly, both with coarse mesh against rodents and fine mesh against insects, and make both removable without tools, because you will be cleaning them. Now the box itself, the absorber, is a sheet of metal painted matte black with high temperature paint. Black because dark surfaces absorb sunlight, and matte because gloss reflects some of it away. The glazing goes over the sunny face. And twin-wall polycarbonate is the usual choice because it is light, tough, and insulates better than single glass, which keeps more of the heat inside the cavity. The cavity between them is where the air travels, and it wants to be a genuine gap rather than a slot. Too narrow, and you choke the flow. Too wide, and the air in the middle never touches the hot plate. The back and sides want to be insulated because heat escaping backwards into the building is heat not doing its job. And the whole assembly wants to be sealed everywhere except the 2 ends, because every leak is a place the stack loses its grip. Sizing is where I will be honest with you. This is not precision engineering at household scale, and the rules of thumb are simple. More height is better. More absorber area is better. A bigger opening at both ends is better, up to the point where the chimney is wider than the flow can fill. If you are ventilating one room, a duct the width of a standard window and running from eave to ridge is a sensible starting point. Build it, measure the airflow, and if you want more, build it taller rather than wider, and measure it properly rather than guessing. Because this is one of the few passive systems where you can see your results immediately. A cheap anemometer costs $20 to $30 and reads airspeed at the outlet. Take a reading at midday and another at 4 in the afternoon, and you will watch the flow climb as the chimney heats. If you do not want to buy one, A strip of light plastic bag taped across the inlet tells you almost as much. On a working system, it stands out straight into the opening and stays there. And put a thermometer inside the cavity if you can. The gap between that number and the outside air is the size of your engine, and if it is small, your glazing is leaking heat or your absorber is not dark enough. Those 3 checks take 10 minutes, and they tell you whether to build taller, seal better, or leave it alone. Now the winter question, because that is the title and it deserves the space, here is what fails, and it is not a fault in the design. It is the same physics running in the season you do not want it. In summer, a solar chimney works because your building is full of air you want rid of, and the chimney gives it a way out. Excellent. In winter, your building is full of air. You have paid a great deal of money to heat, and that air is warmer than the air outside, which means it is buoyant, which means it wants to rise and leave. A solar chimney is a hole in the top of your building. In January, that hole does exactly what it did in July. It lets your warmest air out, and it does something worse than simple leakage, because when that warm air leaves the top, something has to replace it. And what replaces it is cold air pulled in through every gap around every door and window on your ground floor. So you do not just lose the heat that went up the chimney, you increase the draft through the entire building. That is the stack effect working against you, and it is the single reason these installations get abandoned. People build one, love it in August, and then in February they cannot work out why the house is suddenly drafty and expensive. There is a second winter failure, and it is smaller, but worth knowing. In winter, the sun is low and weak, so your chimney is barely being heated. That means it has almost no ability to drive ventilation on demand, but it is still perfectly capable of leaking, because the building's own warmth is doing the pushing rather than the sun. So in the season, it is least useful. It is most harmful. The fix is not complicated, and it is not optional. Every solar chimney needs a damper. A damper is simply a closable plate in the duct that seals it off. You open it in the cooling season, and you close it properly and with a seal for the heating season. Build the damper into the design from the start at a point you can actually reach without a ladder in bad weather. Weather strip it so it closes onto a seal rather than onto bare timber. And put it where you will remember it, because a damper you forget to close in October is a chimney with nothing good about it at all. That is the honest answer to the question in the title. It does not fail in winter because the technology is flawed. It fails because it is a seasonal tool that people leave running out of season, and because a hole at the top of a house is either an asset or a liability, depending entirely on the month. There is one refinement worth knowing, because a few designs turn that winter problem into a winter benefit. Instead of venting your chimney to the outside, you fit it with a diverter so that in winter, the top of the cavity is closed to the sky and opened into the house instead. Now the same black glazed box is still being heated by the winter sun, but the warm air it produces is delivered into the building rather than exhausted from it. The stack still runs, the heat still rises, and you take it indoors. That turns one structure into a summer exhaust and a winter solar air heater, which is a genuinely good use of a sunny wall. It is more work, since you need a proper 2-position diverter rather than a simple damper, and both positions have to seal. But if you are building this on a south-facing wall, in a climate with real winters, it is the version worth designing from the start, rather than retrofitting later. Now the other limits, all of them, the first is that this moves air rather than cooling it. On a night when the outside air is genuinely cooler than the inside, it is superb, and it will flush the house. On an afternoon when the outside air is 100 degrees, all it can give you is a breeze of hot air, which helps a person feel cooler through evaporation, but does nothing to the thermometer. The second is humidity. In a muggy climate, you are pulling damp air through the house. And while airflow feels good, you are not removing moisture, and you may be adding it. The third is that it competes with everything else. If your house has a leaky attic hatch and an open stairwell, your chimney will happily pull its replacement air from those rather than from the cool shaded inlet you carefully built. Seal the paths you do not want before you rely on the one you do. The fourth is that flow rates are modest and hard to predict. This is a gentle, continuous exchange, not a blast. And the fifth is that the sunny side of your building is a finite resource, and a solar chimney competes for it with windows, solar panels, and a trom wall if you were considering one. Now, the safety section. And there is one item here that matters more than everything else in this video combined. Any device that pushes air out of a building lowers the pressure inside it. That is what ventilation is. If your house contains an appliance that burns anything and vents through a flue, a gas, water heater, a furnace, a boiler, a wood stove, an open fire, that appliance depends on its own draft to carry combustion gases out of the building. Drop the pressure inside the house enough, and you can reverse that draft. The flue stops pulling and starts spilling, and combustion gases come into the room instead of leaving it. That is called backdrafting. And among those gases is carbon monoxide, which has no color, no smell, and no taste, and gives you no warning at all. So the rules are absolute. Provide a genuine inlet, sized generously. Most of the risk in this comes from exhausting hard from a tight building with no deliberate way for replacement air to get in. Never operate a solar chimney with a combustion appliance running in the same space unless you are certain there is ample makeup air. If in doubt, close the damper while the stove or the boiler is running. Fit working carbon monoxide alarms, plural, and test them. That is true whether you build this or not, and it becomes more important the moment you start moving air deliberately. And if you have a sealed, modern, well-insulated house with mechanical ventilation, talk to somebody who understands that system before you add another opening to it, because those systems are balanced on purpose. Beyond that, the hazards are ordinary. The chimney gets genuinely hot, so keep it clear of anything combustible and do not let children touch it. Roof penetrations must be flashed properly, or you have traded a heat problem for a water problem, which is worse. And more people are hurt working on roofs than by anything else in this subject, so use proper access and do not work alone. So who is this actually for? If you live somewhere with hot, dry days and genuinely cool nights, this is close to ideal. You run it hard through the evening and overnight. Flush the whole building with cool air, close it in the morning, and coast through the afternoon on the coolness you banked. That routine deserves its own explanation, because it is the difference between a chimney that helps a little and one that transforms a house. It is called night flushing. And the idea is that you are not cooling air. You are cooling the building itself. Every wall, floor, and piece of furniture in your house holds heat. On a hot day, all of that mass warms up, and by evening you are living inside a thermal battery that has been charged with heat all afternoon and will keep radiating it at you until the small hours. Night flushing discharges that battery. You open everything up the moment the outside air drops below the inside air. Run the chimney hard all night and let cool air scour the heat out of the structure itself. Then, critically, you shut it in the morning. Windows closed, damper closed, shades down on the east and south before the sun gets to work. A house run that way starts the day cool and stays cool for hours, because the mass in it is genuinely cold rather than merely surrounded by cool air. Do only the first half and you get a pleasant night. Do both halves and you get an afternoon you did not have to pay for. And that is the entire strategy those courtyard houses were built around. If you have a shed, workshop, garage, greenhouse, or attic that becomes unusable in summer, this is one of the best things you can build. And none of the winter problems apply because you are not heating those spaces anyway. If you live somewhere hot and humid, the airflow still helps how a room feels. But understand that you are moving damp air and not removing any of it. And if you live somewhere with cold winters, build it, use it in summer, and treat that damper as seriously as you treat the chimney on your stove. So this week, here's what I want you to do. First, on the next hot afternoon, hold a lit incense stick at the top of your stairs, at your attic hatch, and at any high opening in your house. Watch which way the smoke leans. That is your existing stack effect, and you may find you already have a chimney you never designed. Second, walk your building and find the shaded side. Stand there in the afternoon and feel the difference against the sunny side. That is where your inlet goes, and the bigger that difference feels, the better this will work for you. Third, look at the tallest sunny face you have and ask honestly how much vertical run you can get. Height is your strongest variable, and it is decided by the building, not by you. Fourth, check your carbon monoxide alarms. Press the buttons, change the batteries. Do this regardless. And fifth, before you build anything, decide where the damper goes and how you will reach it in November. If you cannot answer that, do not start. Tell me in the comments what your summer nights do where you live, whether they drop properly cool or stay warm, and what state you are in. I read every one of these, and that single detail decides whether this is a whole house tool for you or a workshop tool, and almost nobody thinks to check it before building. I'll leave you with what the old boy who trained me said the first time I asked him about venting a hot room. He said, "Any fool can make a hole in a roof. The trade is in knowing where the air comes from to fill it, and in being able to shut the hole again when the weather turns. Make both holes fit the damper, and close it in October."